Hello and welcome to TutorTube, where the Learning Center's lead tutors help you understand challenging course concepts with easy to understand videos. My name is Ethan, lead tutor for biology and chemistry. In today's video, we'll explore balancing chemical equations. Let's get started. Any chemical reaction that occurs needs to be balanced to be useful. The reason we balance chemical equations is because we must obey the law of conservation of mass. However much stuff we have on the left side of the equation must equal however much stuff we have on the right side of the equation. For this example, we have the combustion of ethane to produce water and carbon dioxide. The unbalanced equation has 2 carbon, 6 hydrogen, and 2 oxygen on the left side, and 1 carbon, 2 hydrogen, and 3 oxygen on the right side. To balance this equation, we start by putting a 2 in front of the carbon dioxide to give 2 carbons on the right to match the 2 carbons we have on the left. When we add the 2, we also change the number of oxygen present on the right side. Instead of only 3 oxygen on the right, now we have 4 coming from carbon dioxide and 1 coming from the water. Therefore, 4 plus 1 gives us 5 total oxygen on the right. Next, let's balance the hydrogen. If we place a 3 in front of the water, that gives us 6 hydrogen on the right, which matches the 6 hydrogen on the left. It also gives us 7 total oxygen on the right. To balance the remaining oxygen, we multiply the 2 oxygen on the left by 7 halves to get 7 oxygen on the left. Since we don't want fractions and can't have 7 halves amount of oxygen, we multiply the whole equation by 2. And now all the elements on the left match the elements on the right. We have 4 carbon, 12 hydrogen, and 14 oxygen on both sides. Whenever balancing equations, try to balance the elements that are grouped together in compounds first, then balance the ones that are alone. Like in the last example, we balanced oxygen last since it was alone on the left side of the equation. The elements that are alone have more freedom to be adjusted. Here's another example with aluminum and Fe2O3 reacting to produce iron and Al2O3. On the left we have 1 aluminum, 2 iron, and 3 oxygen, and on the right we have 2 aluminum, 1 iron, and 3 oxygen. First we place a 2 in front of the aluminum on the left to balance aluminum. Then we place a 2 in front of the iron on the right to balance the iron, and we're done. We have 2 aluminum, 2 iron, and 3 oxygen on both sides. Let's try a tougher one. We have Ca3PO42 plus SiO2 plus C producing CaSiO3 plus CO plus P4. For these ones, I like to write out each element on the left and right side to keep track of their amounts. On the left we have 3 calcium, 2 phosphorus, 10 oxygen, 1 silicon, and 1 carbon. On the right we have 1 calcium, 4 phosphorus, 4 oxygen, 1 silicon, and 1 carbon. Let's begin by balancing the calcium. To do so, we put a 3 in front of the CaSiO3 on the right. Nothing changes on the left, so that all stays the same. Now, instead of having 1 calcium on the right, we have 3. Phosphorus remains the same. Instead of 4 oxygen, we now have 10, with 9 coming from the CaSiO3 and 1 coming from the CO. Remember to multiply the coefficients by the subscripts for each compound. Since we have a coefficient of 3 in front of the CaSiO3 and a subscript of 3 on the oxygen, we have 3 times 3 oxygen there, which is 9. And we now have 3 silicon as well, with still just 1 carbon. Next, we place a 2 in front of Ca3PO42 on the left to balance the phosphorus. This gives us a total of 6 calcium, 4 phosphorus, and 18 oxygen on the left. When calculating the number of phosphorus and oxygen, remember that a subscript outside of parentheses applies to each item in the parentheses. Therefore, we have 2 phosphorus times the coefficient of 2 out front to give a total of 4 phosphorus. For oxygen, we have 4 times 2, which is 8. Then we multiply 8 times the coefficient of 2 to get 16, plus 2 oxygen from SiO2 to give a total of 18 oxygen on the left. Silicon and carbon remain the same, and the right side is left untouched. Next, we rebalance the calcium by replacing the 3 in front of the CaSiO3 with a 6. The left side stays the same, but now we have 6 calcium, 4 phosphorus, 19 oxygen, 6 silicon, and 1 carbon on the right. After that, we place a 6 in front of the SiO2 on the left to balance the silicon. The only thing that changes on the left is the number of oxygen from 18 to 28, and the number of silicon from 1 to 6. Everything on the right stays the same. All that's left now is oxygen and carbon. To balance the oxygen, we add a 10 in front of the CO on the right to give us 28 oxygen and 10 carbon. Finally, we balance the carbon by placing a 10 in front of the C on the left. And this is our fully balanced equation. Thanks for watching TutorTube. I hope you enjoyed this video. Please subscribe to our YouTube channel for more exciting videos. Check out the links in the description below for more information about the Learning Center, and follow us on social media. See you next time.